We are starting review in Algebra 2 for your exam that is coming up in a couple weeks. So I went ahead and split these up by sections based off of which I thought would fit best. So the first section that we're going over is on page 67 to 77. It's 2.2 and 2.3, and it's the linear inequality graphs. Now there's a chart on page 68 that explains what some of these graphs are going to look like, but I decided to pick two of the harder types of graphs that will be on your test so that you need to know. So the first one I picked is an absolute value one. Now what an absolute value one means is I have to do two equations here. So I have to do x minus 4 is less than 5, and I have to do negative x plus 4 is less than 5. So I have two different problems here that I have to solve for. I did not give myself a ton of space here, so my writing is going to be kind of small. This one's pretty easy. I just add 4 to both sides, and I end up with x is less than 9. Okay, easy enough. However, over here, I'm going to subtract my 4. I'm going to subtract my 4. I'm going to have that negative x is less than 1. I can't have a negative x. So I have to divide or multiply both sides by negative 1. So I have to flip the symbol. When I flip the signs, so when I make them the opposite of what they are, this is going to flip to where x is greater than negative 1. Okay, so now I need to draw these numbers on my graph. So I'm going to start with, I'll start with 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, negative 1, negative 2. Now they will give you the graphs, and all this test is multiple choice and matching. So I'll give you the graphs and you just have to match it to the right equation. So just pay attention to that part here, okay? Since these two right here are greater than signs, there's no equal underneath it, they are going to be open circles on 9 and an open circle on negative 1. Now I just need to pay attention. X is less than 9, so it's going to go this direction. But it is greater than negative 1, so it's going to go this direction, which means they're going to connect in the middle. Most absolute value inequalities are going to look somewhat similar to this. Okay, so here I have a trinomial. So the first thing I'm going to do is I'm going to factor this. So I'm going to factor it, and it's still going to be greater than or equal to 0. I've got an x and an x. And I know the factors of negative 18 that add together to give me a positive 7 are going to be positive 9 and negative 2. Now I'm going to set both of these greater than or equal to 0. And I have, subtract the 9 from both sides, x is greater than or equal to negative 9. And add the 2 to both sides, x is greater than or equal to a positive 2. Okay, so I need to get negative 9 and positive 2 on here. So I'm going to start at negative 9, negative 8, negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, and 2. For this graph, we have a closed circle on negative 9 and a closed circle on positive 2. We know for this that it's a closed circle because it has the equal sign underneath my greater than symbol. Okay, so because of that, we have that, negative 9 and positive 2. So we have that x is greater than or equal to positive 2. So it's going to go this direction. And somewhere in here, apparently this symbol, oh, no. I am not quite sure. So they have this as going the other direction, as it has to be less than or equal to negative 9. I I'm gonna say, yeah, I don't understand why, but they go this direction. Okay, so you are going to have to match these graphs. Just make sure you're paying attention to where the dots are, because that's the main point of this, is locating these circles are on the X locations. You are going to have one that is really interesting that's going to have 3 different options for you. So you're mainly just looking for where the circles are. That's going to be the quickest thing for putting these with the right graphs. So this one, if I had been given both of these, I would have said, okay, I've got a positive 9 and I've got a negative 9. Okay, this one had the negative 9, this one had the positive 9. So then I know which one goes where. You're going to have to solve them anyways, but just kind of go for it after that. Okay. Moving on to page 99 in 2.5. So it's about complex numbers. Now, the only thing you need to know about complex numbers is that their standard form is a plus 2bi. So some examples of that are like 2 plus 7i, negative 4 minus 8i, things like that, where I comes afterwards. Now remember, I always like to write my i's in cursive. Theirs is going to just be a simple I. It's the same thing. I like the cursive one better. But that's all that is from 2.5. So 3.2 is equations with integer exponents. So I have an example here. And what I'm going to tell you is these are the ones that you solve using u. So I'm going to look at this and I'm going to say this is u squared. It's a squared squared minus 3a squared plus 2 equals 0. And then you plug your u equals a squared. The biggest hint here is look at what this middle term is to find out what your u is going to equal. It's going to make it a lot easier. You're not going to have one of the ones that deals with fractions because, again, this is a multiple choice question, so they want to make it as quick as possible. So I'm going to show you how we solve that. U squared minus 3u plus 2 equals 0. We are going to separate this, and we're going to have u. It's a positive 2 and a negative 3, so that means this is going to be a negative 2 and a u with a negative 1. Okay, those are just the factors that make positive 2, so negative 2 times negative 1 equals positive 2, but negative 2 plus negative 1 equals negative 3. Okay, instead of going and leaving it as u minus 2 equals 0, I'm going to plug this back in now, and I'm going to have a squared minus 2 equals 0. I'm going to have a squared minus 1 equals 0. So we add the 2, we have a squared equals 2, which gives us a equals plus or minus the square root of 2. Remember, when you take the square root of things, you have to keep that plus or minus there. So there's one of our answers. And then here's going to be another one. A squared equals, let me see, add the 1 both sides. A is going to equal the square root of 1, plus or minus, which in this case, A is just going to equal plus or minus 1. So here we have both our answers. Now what they're going to do is they're going to have something that looks like this. So they would write it as A equals plus or minus 1, comma, plus or minus square root 2. So as long as you are factoring properly and then plugging it in after you factor, that's when you plug it back in, okay? So you're going to plug them back in after you factor. When you're solving, you're going to be able to find your final answer. So let's flip this over and see. We are in 4.3. Yes, we're moving on to chapter 4 here with this. So the first one is on page 171. It's about inverse and direct variation. So remember, direct variation was the multiplication, whereas inverse is the division. So what it's going to do is it's going to give you a problem like this. Let x and y be inversely related. If y equals 3 when x equals 2, find y when x equals 4. So the first thing we have to do is we have to use y equals 3 and x equals 2 to find our constant, okay? So I'm going to have y, let me set that up. That's going to be 3 because I know that y is 3. So 3 equals k divided by 2. Multiply both sides by 2, and I'm going to have 6 equals k. So now we can set up y equals 6 divided by 4. And then we can simplify this into 3 halves. And there we have it, y equals 3 halves. Okay, so make sure you know the formula for inverse variation, which is right here for you. Right there, make sure you know that. Moving on, in chapter 4, we have domain of rational expressions. Now, if you guys remember this, there is a big fancy chart on page 186. So I am going to give an example of this type of problem here, of finding the domain of this problem. But you want to review that chart. Just make sure you know some of the simpler ways of doing this. So I'm going to look at this. I'm going to say that's a linear equation because it's set up as mx plus b. I've just got a singular x. That's how I know that. And there are no other fractions or anything in the denominator. So to find the domain, I'm going to set the denominator equal to 0. Add my 6, I'm going to have x equals positive 6. So because there are no other restraints with this, it is actually all real numbers except when x equals 6. Because if I were, the whole point of domain is if I were to plug the 6 in here and I'd have 6 minus 6, I would have an undefined problem. I was just talking to Algebra 1 about this. I cannot have undefined problems, so I have to state my domain so that I know, oh, this problem could actually be any number except when x is 6, because if x was 6, that would give us undefined. You're going to have a problem that's also pretty much just as simple as this, but look over that chart just to make sure that you understand how that works. And if you have any questions on this, let me know, because I can put out a more detailed version on this section. I know I love this part because it's really just dealing with the denominator and you get to ignore part of the equation. But if you have any questions, let me know. Okay. And our final section is talking about translations of parabola graphs. So I have here an entire example of a problem. So I have a times x minus h squared plus k. So what I have here is a little cheat sheet. So I have, if a is negative, it's a vertical reflection. If the absolute value of a, so again, we're looking right here for right now, this first 3 is just over a. If the absolute value of a is greater than 1, so if it's a whole number, it's actually a vertical stretch. So it's going to make it look tall and thin, okay? If a, the absolute value of a is less than 1, so if it's a fraction, it's a compression. So the fractions, the compressions are going to make them look like the really wide ones. Okay, so it compresses it down. Whereas if it's a whole number, it's going to stretch it out. Okay, if h is greater than 0, it's going to shift right. So that's this term in here. Remember, we're focusing on this. We're not looking at the negative sign in front of it. We're just focusing on the h. So if h is positive, so if that's a minus, it's going to shift right. It's a horizontal translation. Okay, it's a horizontal shift to the right. If h is negative, making this a positive, because remember, it's the opposite of that sign right there. So if h is a negative, and that means that's a positive symbol, it's going to shift left. Again, it is a horizontal translation. You are really only going to have to deal with vertical reflection, vertical stretch, vertical compression, horizontal translation, or vertical translation, so just pay attention here. All of these would probably have, they'd probably put it with no k. They're not going to make you do more than one thing. So they're just going to be like, oh, ignore k. So you're looking for what you have currently. So you're going to have to say, oh, I have ax squared. Cool. I've got one of these 3. Oh, I have parentheses x minus 2 squared. Oh, that's just dealing with horizontal. So you have to pay attention to that. And then this little outlier over here, this is k. He is our vertical translation. So if k is greater than 0, it's a positive shift up. If k is less than 0, it's a negative shift down. So if it's positive, it's a shift up. If it's negative, it's a shift down. Okay, make sure you double check this. I put the page numbers. This is page 200 to 205, 4.8. You can go back and look over your notes. You guys should have all of those with you. Make sure you look over your notes for these. You will have a matching section on this where it's going to give you the different formulas, and then I'm going to ask you which one it is. So I may give you like x squared minus 2, and you're going to have to say, oh, okay, cool. I have no h or a, so it's going to be down here. I have a negative 2, which means it is vertical translation. Okay, I'll see you tomorrow as we move forward with this review.